Hi, friends. It has been quite a while, so I decided to come back and try to revisit where we left. I left when we were beginning to implement the project which were approved by KSAP, and I was retiring at that time. It is important to understand that it is retirement based on age, not based on loss of mind or loss of interest or loss of passion. So I decided to come and share with you what I saw in my mind's eyes regarding the projects that you are implementing. Well, I did not participate in their implementation, but my mind was still there. I was particularly interested in Kabaa Irrigation Scheme. There was critical problem issues that we were addressing in this scheme, and I personally developed this concept because of the passion that I had. Okay, I led the team in developing this concept, but it started from me, to be honest. And the critical problem issues that were being addressed in Kaba is what I wanted us to revisit and see whether the outcome of the research addressed them and whether the farmers took them and really used them to assist them to address the problem. The critical problem issue which were being addressed in Kabaa Irrigation Scheme were as follows: deteriorating quality of agricultural products through irrigation using polluted water had a negative impact on human health and income through increased chemical degradation. Now, the sharp decrease in the demands of agricultural products from this scheme was such that many farmers lost their contracts for export markets, while those supplying the local markets continue to do so with serious health implications. The analysis of cancer diagnosis in the area between 2015 and 2019 showed an increasing rate of cancer related challenges, leading to the establishment of cancer referral center with a total of 520 cancer cases within the study period. In this regard, the teams which were to be promoted was phytoremediation to purify the polluted water used for irrigation. The other one was integrated soil structural and fertility management for improved soil buffer capacity to detoxify the excess chemicals coming through the irrigation water. Now, the excess chemicals were evidenced in extremely high level of heavy metals in the harvested vegetables as reported by us in the baseline report, where the level of lead, cadmium, and zinc was found to be 131, 4.8, and 121 milligram per kilogram. Now, these figures were found to be far much above the World Health Organization thresholds. Now, to solve this problem, there was a pathway that we need to follow. Now, these pathways were actually the planned field activities which we were supposed to do. Unfortunately, we don't do them because at the time now that I left the office. Now, this started like this. Number one, developing soil map based on the limitations described in the problem statement picked from the project document. The second one was selecting the research sites and the most suitable areas for water purification structures. The third one was assessing the hydrological systems and wetland potentials for phytoremediation processes. The fourth one was mapping out the distribution system of polluted water and collecting the parameters required for the design of water purification structures. Now we are supposed to go back to the farmers, tell them that the level of heavy metals in the plants, in the soil, in the water were above or below the thresholds, and then demonstrate to them those technologies which you are actually advocating as our teams for purifying the water and also improving the soil quality and its capacity to detoxify the excess chemicals. Now, the results obtained would help the farmers to solve these problems. The question that the farmers asked were which technology was sustainable and how much did this technology reduce the level of those pollutions towards the threshold required, and which one was most promising. So, did we do that? That's the question we need to ask ourselves and then answer it sincerely. Thank you very much.